Welcome to the Deep Dive, where we cut through the noise and get straight to the insights. Today, we're plunging into a topic that's, well, it's fundamentally reshaping how we interact with data. I'm talking about the incredible power of large language models, or LLMs. From summarizing complex docs to generating new content, LLMs seem to be everywhere. But the real magic, the true transformation, happens when they're not just a novelty, but genuinely integrated into our existing data ecosystems. And that's precisely the core of this deep dive. The crucial, often challenging puzzle of effectively integrating and scaling these LLMs with existing data infrastructure.
Yeah, it's a big one.
It's one thing to run a single prompt in a chat window, right? It's another entirely to process petabytes of data with AI reliably and securely.
Exactly. And our focus today is on a fascinating document that aims to tackle this head-on. It's a Request for Information, or RFI, from Snowflake. And this RFI is specifically designed to gather insights on how to build scalable, automated pipelines for LLM-driven data. So it gives us a unique glimpse into the future of their platform and how they envision AI working within it.
So our mission for you, our listener, is to understand how Snowflake is approaching the simplification of AI integration. We'll explore how they're leveraging both their native capabilities, like Snowflake Cortex and external LLMs, to achieve fully automated, high-volume data processing.
That's the plan.
And our sources for this deep dive are the detailed RFI from Snowflake itself. Let's uncover these insights together. All right, so the promise of LLMs is immense. The practicality of getting them to work at scale with your existing data is the real hurdle.
Definitely.
Snowflake, through this RFI, is clearly trying to articulate how they plan to clear that hurdle. What's the fundamental goal they're trying to achieve with these LLM pipelines?
Okay, so the primary goal of this RFI is, well, it's to gather detailed responses on how to best implement and scale Snowflake-based pipelines for large language model processing.
Right, implementation and scaling.
Yeah. The emphasis is squarely on achieving fully automated, high-volume batch processing and real-time AI data workflows.
Okay.
What's particularly compelling is their dual focus, leveraging both their own native Snowflake Cortex capabilities and seamlessly integrating with external LLMs. It gives users flexibility.
That makes perfect sense.
Oh, yeah.
And beyond just that core purpose, what are the key architectural considerations that Snowflake is highlighting for robust LLM integration?
Yeah.
They clearly have a roadmap in mind for what success looks like.
They absolutely do. And the RFI lists 5 critical considerations. First up is data ingestion.
Okay.
Making sure you can efficiently load, say, CSV data files into Snowflake tables, supporting internal staging, automatic compression, that sort of thing.
Standard, but crucial. What's next?
Second, dynamic LLM task processing. This is about the ability to classify tasks and execute functions automatically without needing to hard-code specific LLM calls for every single task type.
So it's smarter routing.
Kind of, yeah. More adaptable. Third, scalability. This is huge. Supporting high-volume batch processing and enabling real-time automation using things like Snowflake streams and tasks.
Streams and tasks, right? We'll probably come back to those.
Definitely. Fourth is automation, building fully automated workflows that trigger the LLM processing as soon as new data lands, making it truly hands-off.
Nice. And the last one.
And finally, number 5, governance and security. Basically, utilizing Snowflake's inherently secure, governed, and scalable infrastructure, ensuring data privacy and compliance throughout.
So when you look at those 5 points together, ingestion, dynamic processing, scalability, automation, governance, what's the single most significant takeaway for a company trying to adopt LLMs today?
That's a good question. I think it's really about control and flexibility.
Control and flexibility. How so?
Snowflake is essentially saying, look, we're giving you the tools to manage your entire AI journey within your secure data environment, whether you use our native capabilities or your preferred external models. That's a crucial insight, I think. It's not just about running LLMs, but running them securely and scalably within your existing data governance framework.
Which is a huge pain point for many organizations.
Yeah,
right?
exactly. A massive pain point.
That's a powerful statement. So they've laid out their foundational architectural needs.
Okay.
But what do these LLM functions actually look like when you're working with them inside Snowflake? This is where it gets really tangible.
Yeah.
RFI provides concrete examples, right?
It absolutely does. And this is pretty neat. Snowflake has abstracted complex LLM functions into straightforward SQL commands using Snowflake.Cortex function.
Okay, so it's SQL-based.
Yes, making them incredibly accessible directly within your data warehouse. For instance, for text summarization,
Yeah.
you could input something like, cloud computing offers scalability.
Right.
And get a concise output, like cloud computing provides scalable solutions. The sequel for this is simply select snowflake.cortex.summarize.
Wow. Okay. That's simple.
Pretty much. Or for text classification, say classifying sentiment, you might input, this product is excellent, very happy with my purchase.
And it outputs.
Positive sentiment. And the command is select snowflake.cortex.classify sentiment. Again, quite direct.
Okay. What else?
Text generation is equally simple. Write a professional email to a client about a delivery delay. That becomes select snowflake.cortex.complete. Write a professional email.
Complete for generation. Interesting.
Yeah. And for question answering, you can ask, what is the capital of France? And get Paris. Again, using snowflake.cortex.complete.
So complete does double duty there.
It seems so, depending on the prompt. And there are others mentioned too. Translation, code generation, content categorization, sentiment analysis again, named entity recognition, all callable via these intuitive SQL commands.
Wow. So snowflake.cortex, summarize, classify, complete. They really abstract that complexity away.
Exactly.
That's incredibly powerful. It keeps everything unified within the SQL environment people already know. So that's what individual tasks look like. But the RFI also details how to automate these into a full pipeline. How did that workflow operate?
Right. It outlines a clear step-by-step process. Step one is basically to create the target table. You define a table structure, let's call it Elm tasks, maybe with columns for a task ID, the cast type like summarize or classify, and the input text.
Okay. Standard table setup.
Pretty much. Then step two is load your CSV via an internal stage. You'd use a PUT command to upload your CSV file into Snowflake's internal stage.
Which is like their secure file area.
Exactly. Think of it as Snowflake's secure, optimized file system within your account. With automatic compression usually. After that, a copy Y into command efficiently loads that staged data into your Elm tasks table.
Okay, standard data loading. PUT, then copy OT.
Right. A standard, robust pattern, but now applied directly for LL inputs.
Got it. What's step three?
Next, step three is process with a dynamic LLM query. This is where the intelligence we talked about kicks in. You write a select statement that uses case logic.
The case statement.
Yeah. So if the task column in your table says summarization, it dynamically calls snowflake.cortex, summarize on the input text. If it's sentiment analysis, it calls snowflake.cortex.complete with a sentiment prompt, and so on. It produces an LLM output column.
So one query handles different jobs based on the data itself.
Precisely. This means one query can handle multiple types of LLM tasks based on your data. Very efficient.
And then there's an automation step.
Finally, step four is the optional automation via Snowflake streams and tasks. This is the continuous processing piece that makes it truly automated.
Okay, this sounds important.
It is. You create or replace stream on your LLM tasks table. A stream basically tracks changes new rows, in this case to the table.
Like a changelog.
Sort of, yeah. It captures the delta. Then you create or replace tasks that's scheduled to run, say, every minute.
A scheduled job.
Right. And this task automatically inserts results into maybe an Elm results table by applying that same dynamic LLM query, but only to the new records that have appeared in the stream.
How does it know what you're new?
It uses special metadata columns that streams provide, specifically metadata action insert. This tells the task to only process the fresh rows that have just arrived.
So it's not reprocessing everything each time.
Exactly. It makes the process incredibly efficient for continuous workflows.
That automation piece is a real aha moment for efficiency, enabling continuous LLM processing as new data arrives without any manual triggers. It's like setting up a smart factory line for your data.
That's a good analogy.
But the effectiveness of that pipeline and what you can do with it really hinges on the underlying LLMs themselves. The RFI dives into something called context window capacities. Can you tell us what those are and why they're so crucial?
Sure. LLM context windows are essentially the maximum amount of text measured in tokens, which are roughly words or parts of words, that a model can consider at once when generating a response or performing a task.
The model's short-term memory, basically.
Kind of, yeah. It's a critical factor because it determines how much information an LLM can understand or remember from your prompt, or maybe a long document you feed it.
Okay. The larger the context window, the more complex or longer documents an LLM can handle effectively in a single go. If you try to feed it more than its window allows, well, it simply won't see the extra information.
It just gets ignored. Got it. So how do different models compare?
The RFI compares several platforms and models. Snowflake Cortex, their native LLM, typically supports context windows of about 4,000 to 8,000 tokens. So 4K to 8K.
Okay, that's the built-in option.
Right, it's built-in, highly scalable, SQL-based. Then, through external LLM integrations via Snowpark, that's Snowflake's developer framework, you can access much larger capacities.
Like what?
For instance, OpenAI's GPT-4o offers around 16,000 tokens, so 16K. Anthropic's Claude 3, also accessible externally, boasts a substantial, roughly 200,000 tokens.
200K. Wow.
Yeah, making it excellent, as the RFI notes, for long documents and complex reasoning. But the standout, highlighted in the RFI, is Google's Gemini 1.5 Pro.
Okay.
Available via Snowpark, it offers an exceptional, wait for it, roughly 1 million tokens.
A million. Seriously, 1 million tokens. It's specifically highlighted as exceptional for long context processing and is currently the largest available, according to the document.
That's incredible. Are there others mentioned?
Yeah, it also mentions other enterprise services like Azure OpenAI Service and AWS Bedrock, which also offer various models with differing capacities accessible externally.
What's truly powerful here is the flexibility Snowflake offers, right? Allowing you to leverage either the efficient native Cortex for maybe more direct SQL processing, or tap into the immense context windows of external models for more complex long-form tasks. So if I'm building a new LLM application, how do I actually choose which one to use given these capacities?
It means you have clear options tailored to different use cases, right?
Yep.
Snowflake Cortex is probably great for efficient, direct SQL processing of smaller context directly within the Snowflake platform. Quick summaries, classifications, maybe short generations.
Makes sense.
But if your tasks involve analyzing very long documents, complex reasoning over vast amounts of text, or maybe require the absolute cutting-edge capabilities of advanced models that aren't yet native, then Snowpark enables you to seamlessly access those external LLMs with massive context windows. And currently, Google's Gemini 1.5 Pro leads in sheer token capacity.
So the choice really depends entirely on your specific workload and how much context you need.
Exactly. It's about matching the tool to the job.
Now, for the real-world deployment challenges, the RFI tackles some really important questions about how to manage these LLM workloads, especially concerning scalability and security. Let's start with batch sizes. What's the maximum expected batch size that can be efficiently processed?
Okay, batch sizes. Snowflake's architecture is designed for, well, very high scalability. It's capable of processing from thousands to millions of records efficiently. It really depends on the size of the virtual warehouse you're using.
Right, the compute power.
Exactly. But for optimal performance, the RFI recommends batch sizes somewhere between 100,000 and 500,000 rows per batch.
100K to 500K rows. That seems like a practical range.
Yeah, it seems to be a sweet spot that balances processing time and resource utilization. For extremely large batches, like millions, they suggest configuring multi-cluster warehouses or just scaling up your existing warehouse significantly to handle the load.
Okay, that 100K to 500K range is useful. I remember trying to push millions through a single queue once. It did not end well.
No, I bet not.
This emphasis on batching and multi-cluster warehouses really highlights how foundational that is for LLM scale. But what about fluctuating workloads? LLM usage can be spiky, right? Very unpredictable.
Yeah, absolutely. Fluctuating workloads are a common and significant challenge.
So how does Snowflake optimize for those unpredictable spikes?
It addresses this pretty effectively with its auto-scaling and multi-cluster warehouse features. You can configure them to automatically start or stop additional clusters based on the query load.
Okay.
So using max a cluster count for multi-cluster warehouses lets you handle unpredictable spikes by scaling out horizontally, adding more compute power on the fly.
And then scaling back down.
Exactly. Enabling auto-suspend and auto-resume helps manage costs efficiently by pausing warehouses when they're idle. You can also fine-tune query concurrency settings to optimize how bursty LLM tasks are queued and processed. This elasticity allows Snowflake to adapt to demand without you needing to manually intervene.
That elastic scaling sounds crucial. So how does Snowflake Cortex, the internal LLM service, handle things like rate limiting and failover if you have many concurrent LLM requests hitting it?
Right. For Snowflake Cortex, it enforces internal concurrency controls. These are influenced by your warehouse size, bigger warehouse, more concurrent requests generally.
Okay.
If the request rate exceeds that capacity, additional requests are intelligently queued up. Snowflake doesn't publicly expose strict rate limiting thresholds per se.
So you just need a big enough warehouse.
Pretty much. The best practice is to ensure you manage high concurrency scenarios with adequately sized warehouses. For failover, Cortex provides high availability within the Snowflake environment. If a service instance has an issue, the platform automatically reroutes requests to healthy nodes.
So it should be seamless for the user.
Mostly, yes. It aims for a seamless experience. However, for external LLMs, like calling OpenAI via Snowpark.
Ah, okay. Different story?
Yeah, different story. Rate limits and retries must be handled at your Snowpark Python code level or within your application logic. You typically need to build in things like exponential backoff and retry mechanisms yourself to ensure resilience against external API limits or temporary glitches.
That makes sense in relying on Snowflake's internal magic for Cortex resilience. But then for external LLMs, it's back on us, the developers, to build in that robustness.
That's the trade-off.
Are there common pitfalls people hit there, like forgetting the back off?
Absolutely. The biggest one is probably not building robust retry logic with exponential backoff for those external calls. Without it, a temporary rate limit or a brief network blip can cause your whole process to fail, and it can be hard to recover gracefully.
Yeah, I can see that. Understanding those distinctions is crucial then.
Definitely, for designing resilient applications.
Security is paramount, of course, especially when dealing with potentially sensitive data flowing into these models. What are the key security controls for internal versus external LLM API data flows? There's clearly a big difference, right?
This is a critical distinction, yeah. It really can't be overstated. For internal LLM processing with Snowflake Cortex, security is fully managed within the Snowflake environment.
Okay.
And crucially, no data leaves the Snowflake platform. That's the key point. Governance and access control are handled through Snowflake's standard role-based access control, or RBAC, and all its native security layers. So it's highly secure by design.
Because it never leaves the building, so to speak.
Exactly.
Right.
However, for external LLM APIs like calling OpenAI or Anthropic via Snowpark Python, the data does flow outside Snowflake.
Right. That's the core issue.
It is. This means you need explicit network configuration. Critical measures like encryption and transit using HTTPS are absolutely essential. Robust API key management and token-based authentication are paramount to prevent unauthorized access.
How do you manage those keys securely?
Well, the RFI recommends using secure external stages, maybe VPNs, or Snowflake's private connectivity options like AWS Private Link or Azure Private Link to minimize data exposure risks over the public internet.
So trying to keep the connection private if possible.
Ideally, yes. The onus is definitely on the user to secure that external pathway because Snowflake can't directly govern or protect data once it leaves its boundaries.
So Cortex is beautifully secure within Snowflake's walls, but once you step outside to external APIs, the burden shifts entirely to the user. That feels like a significant responsibility.
It is.
Does the RFI offer any specific guidance on how to manage those external API keys or ensure proper encryption beyond just use HTTPS and use private link?
It doesn't get into the nitty-gritty of specific key management systems, no. But it strongly implies that standard best practices for secure API key storage should be used.
Like secrets managers.
Exactly, like using secrets managers, secure environment variables, or other dedicated vaults rather than, hard-coding keys in your scripts.
Please don't hard-code keys.
Right, please don't. The emphasis on private connectivity also highlights that the most secure approach minimizes public internet exposure for sensitive data flows. It's about taking that principle of no data leaves Snowflake for Cortex and extending it as much as realistically possible for external interactions, too.
Makes sense. Okay, finally, what about performance and throughput? What are the best practices for partitioning LLM tasks to enhance parallelism and maximize throughput? Because ultimately, everyone wants to go faster.
Yeah, speed is always a factor. To maximize throughput, several best practices are highlighted in the RFI. First, partition your input data based on task type.
Okay, separate the summaries from the classifications.
Exactly. Separate them to enable task-specific parallelism. Second, employ multi-threaded or multi-session execution. Each session or thread can handle a different partition of the data in parallel.
So divide and conquer.
Pretty much. Third, leverage Snowflake's result caching. This is important. If an LLM query has been run recently with the exact same inputs, Snowflake can often serve the result directly from its cache.
Saving time and credits.
Exactly. Saving reprocessing time and cost. Fourth, ensure your warehouse size matches the parallel load you're throwing at it. A larger warehouse naturally supports higher parallelism.
Right, size the compute.
Right. And when you're automating with streams and tasks, you can configure parallel tasks per stream for better scaling, processing multiple batches off the stream concurrently.
Okay. Anything else for external calls?
And if you're using Snowpark Python for external LLMs, it's advised to employ parallel API calls, making multiple calls to the external API simultaneously, but you must combine this with those retry mechanisms we discussed.
Because rate limits will hit you faster with parallel calls.
Precisely. You need to handle external service rate limits and transient errors gracefully when you scale out your calls like that. So yeah, think of it like a well-orchestrated symphony. Each section has its part, they play in parallel, but they all need to stay coordinated to get the job done quickly and correctly.
What a deep dive. We've really covered a lot there. We've seen how Snowflake is positioning itself as, well, a robust, scalable, and secure platform for integrating these diverse LLMs into modern data pipelines. By simplifying complex AI tasks through familiar SQL, like with Cortex, and providing pathways to powerful external models via Snowpark, they're truly enabling a new era of data processing. They seem to be unlocking capabilities that were previously incredibly complex, maybe only accessible to specialized teams.
I think that's a fair summary. They're lowering the barrier to entry while providing the rails for doing it securely and at scale. So what does this all mean for you, the listener? As LLMs continue to evolve so rapidly, the ability to seamlessly integrate them into existing data pipelines while effectively managing scale, cost, and security. Well, it's no longer just some technical detail, is it?
No, it feels much more strategic now.
Right. Exactly. It becomes a critical strategic capability for transforming raw data into truly actionable intelligence. So the question becomes, how will you harness these powerful tools to unlock new insights and drive innovation in your own data endeavors? And what will you build next?